And in the next slide here, we're going to introduce the inverse cosine function. Notice it's defined in a very similar way to how we defined the cosine or the inverse sine function, but for cosine inverse, we're going to have a different restriction. So I left that blank here so that we can think about what this restriction needs to be. So we should think about when cosine is 1-to-1. We know that cosine, the graph of cosine, is very similar to the graph of sine. It's just sort of shifted over a little bit. And we notice that at x equals 0, so if I'm looking at y equals cosine x here, at x equals 0, it has that peak, and then at x equals pi is where it reaches that second peak. So by restricting our domain here from 0 to pi, cosine is 1-to-1. On the interval from 0 to pi. So when we're defining the inverse cosine function, we're going to specify that its output values here will always be a value between 0 and pi. And that will ensure that we have a 1-to-1 function. And again here, if I'm thinking about the cosine inverse applied to cosine x, well, we know this has to be true for x between 0 and pi. Because there again, we want to make sure that the cosine inverse function is well defined. So for cosine applied to cosine inverse, we know this will equal to x for x between -1 and 1. Now to get the derivative of cosine inverse, we can basically apply the same strategy we did before, but when we're developing the formula for the derivative, you notice that the sign changes, so it becomes negative now. And in this case, that's because if we were to walk through that same procedure that we did before, right, that if I take y equals to cosine inverse of x, so x equals cosine of y, and then I take the derivative of either side here, you get 1 equals negative sine y times y prime. So y prime would be 1 over negative sine y. So that's where the negative comes from. And then we would know that that's equal to the negative square root of 1 minus cosine squared, which is equal to the negative 1 over the square root of 1 minus x squared. Okay, so it's the same derivation that we did before. Okay.